All right, today we're going to try and build a bridge between two worlds in physics that feel like they shouldn't even be in the same universe. We're talking about the super weird, orderly realm of quantum mechanics and, well, the everyday idea of temperature. How on earth could these two things be connected? Let's find out.
I mean, think about it. What really connects the mind-bending weirdness of a single, tiny atom to something as vast and simple as the warmth of the sun? It's a huge puzzle. Because on one side, you've got these perfect, predictable rules for the quantum world. And on the other, you have our world, the messy, hot, statistical reality we live in. How do you get from one to the other?
And that divide it's just massive. You look at the quantum realm, and it's all about pure, clean, predictable states. It's coherent. But then you look at our world, the everyday world of heat and energy, and it's a mess. It's all statistics and averages and chaos. It really does feel like we're talking about two completely different rule books for the universe.
So, what gives? Are they actually different sets of laws? Or, and this is the really cool part, are they just two sides of the same undiscovered coin? A fascinating new paper is suggesting that maybe, just maybe, we've been missing a huge piece of the puzzle this whole time.
And this new idea it's a bit of a mind bender. It proposes that the missing link isn't hiding in space or time. The idea is that the universe might have another, hidden dimension we've just completely overlooked. Not like a sci-fi dimension, but something woven right into the fabric of reality, the dimension of scale itself. So what if the universe isn't just organized by where things are and when they happen? What if it's also organized by their size? What if reality itself has preferred sizes, like a built-in grid that structures everything from the tiniest particles all the way up to galaxy clusters? Okay, to really get our heads around this, the paper gives us this brilliant analogy. Let's try to visualize reality using a whole new geometric structure. Think of it like a giant cosmic ladder. This scale ladder is basically a new way of mapping the universe. The theory goes that things like particles or atoms or even stars don't just pop into existence at any old size. No, they're most stable. They prefer to exist on specific rungs of this ladder. It's a framework that organizes everything by size, from the subatomic to the truly cosmic. And here's where it gets really good. Because once you start thinking with this ladder, it gives us a completely new and, honestly, much more intuitive way to understand that old mystery, the connection between heat and the quantum state.
So let's walk through this. Imagine a quantum particle. When it's in its pure quantum state, it's perfectly coherent and predictable. Why? Because it's sitting nice and neat on a single rung of our scale ladder. Simple enough, right? But now, what's temperature? Well, in this model, heat is just the energy that lets the particle move between the rungs. When you add a lot of heat, you give it enough energy to spread out, like a fuzzy cloud, across many rungs at once. And that process, that transition from being on one neat rung to being smeared across many, that's decoherence. It's how the orderly quantum nature gets lost. It's not some abstract magic, it's just spreading out on the ladder.
Okay, I'll admit that's a beautiful picture. It's really elegant. But this is physics, not just a cool idea. So the big question is there any actual evidence for this? Does this hidden ladder structure really exist? So, to try and find it, the scientists behind this paper did something really clever. They took a whole bunch of fundamental numbers from physics, things we've measured very precisely, like the mass of an electron or the background temperature of the universe. They combined them into 63 key energy ratios. Then they basically asked, if we plot these values on our new scale dimension, do they land randomly, or do they seem to prefer landing on or very close to the rungs of our proposed ladder? And the results? Well, they're pretty fascinating. See, if it were all just random, you'd expect about 4% of these fundamental numbers to land near a rung, just by pure luck. But what the actual data showed was 7.9%. That's almost double what you'd expect from chance alone. It's a really strong statistical hint that something not random is going on. Now, we have to be super clear here. As the paper itself points out, this is not the final, aha, we've proved it moment. That's not how science works. But it is a really, really powerful hint. It's a breadcrumb trail telling physicists, hey, you might want to look over here. Because, the real test of a great theory isn't just that it explains what we already know. It has to make new predictions that we can go out and test. If this whole scale ladder idea is real, it can't just hide. It has to leave some kind of fingerprint, a smoking gun in our data. And this theory makes a very specific one. It predicts that if you take really high-precision measurements of certain things and plot them against scale, the line shouldn't be perfectly smooth. Instead, you should find these tiny, repeating wiggles in the data. Think of those wiggles as the faint echoes of particles hopping from one rung of the ladder to the next. That's the signature we're looking for. So, where do we go looking for these wiggles? And this is where it gets super exciting for physicists. We can now go back and look at a whole bunch of old, high-precision data. We're talking about everything from the light from the early universe, black body radiation, to the weird Casimir effect, and even the performance data from our most advanced quantum computers. The theory predicts this pattern is already in our data, just sitting there, waiting for us to find it. And all of this leads to one last, really mind-bending thought. This whole idea suggests there's a hidden geometry to our reality based purely on size. And if a dimension as basic as scale has been hiding in plain sight this whole time, well, it just makes you wonder, right? What other hidden patterns, what other secret geometries are written into the fabric of our universe, just waiting for us to find them?